Okay, so today we're going to have a look at finding the slope of a line or a line segment using the following example. So in this coordinate plane, we're given 6 points, A, B, C, D, E, and F. And then we're asked to find the slope of AB, the slope of CD, the slope of EF. And then we're asked which lines are parallel to each other and which lines are perpendicular to each other. So we'll come to them towards the end. The main intention of this video is for you to be able to find the slope of any line if you have 2 points on that line, and then what that slope can tell you about the line. We'll look a bit into that later. Okay, now, like everything else in coordinate geometry, we tend to have a formula for this. So, slope of a line segment. Given 2 points on a line segment, so x1, y1 and x2, y2, the slope of that line is denoted by m, so m normally stands for the slope, and it's equal to y2 minus y1 over x2 minus x1. Okay, let's have a look applying that formula to the first part. So for part 1 of this question, I have to find the slope of AB. So I'm going to call that M1 for the minute. And I have A is my point here, and that's minus 3, 0. And then I have my point B up there, which is 4, 3. So what I'm looking for here is the slope going from A to B. Okay, so first things first, like the other few videos, we first establish our x1 and our y1. So the x and y values of our first point, and our x2 and y2 values. Okay, and again, my B, the x and y points in my B could have been my x1 and y1, either. It doesn't matter. Okay, as long as this x is paired with this y. So x1 and y1 here, and x2 and y2 here together. Okay, so then I can say my slope of this first line here, so m1, is equal to, so using my slope formula, it's y2 minus y1 over x2 minus x1. So then I'm just going to fill in my values. So my y2 is 3 and my y1 is 0. So 3 minus 0 all over x2, which is 4, minus my x1 value, which is minus 3. I always tend, when I have a minus, I tend to sub it in brackets so I can keep track of my minuses. Okay, and then simplifying the top and bottom, we have 3 minus 0 is 3. And then we 4 minus minus 3. So that's going to be 4 plus 3, which is 7. Okay, because that minus is going to multiply by that minus and give me a plus. So that means M1 is equal to 3 over 7. Okay, not so bad. So then my second question is asking me to find the slope of CD. So that's this line here, going from C to D. Okay. Okay, same thing again. I'm going to call this M2, and that's what we're looking to find. And I have my point C is here. So that's minus 2 minus 2. And then my point D is here, and that's the point 5, 1. And just to make this a little bit easier to read, I'm just going to draw a line between the first part and the second part. Oh, that didn't work very well. Okay, you get the idea. We're going on to part 2. Right, so again, I have my C and my D, and I need to find the slope of this line. So I'm going to establish my x1 and y1 values. And then I'm going to use my formula. So m2 is equal to y2 minus y1 all over x2 minus x1. So that's equal to 1 minus 2, because my y2 is 1 and my y1 is minus 2, all over x2 minus x1. So that's 5. And again, I've got minus 2. Okay. And then last thing is to simplify. So I've got 1 minus 2, which is 3, because that's going to become 1 plus 2 due to the 2 minuses. And then on the bottom, I got 5 minus 2. So that's going to be 5 plus 2, which is 7. So that means m2 is equal to 3 over 7. So that is the slope of CD. Okay, and what you'll notice is that AB and CD have the same slope. Okay, and we'll come back to that later. Keep that in mind. Okay. Let's move on to the next part. So I'm gonna slide this over here for the minute. Like that. Okay, class. Part 3. Find the slope of EF. Okay, so I'm going to call that M3, and that's what we're looking for. Third line, third slope, M3. Okay, so from E to F, that's from the point E over here to F. So this pink line here. Okay, and as you can see from this diagram, the slope of E to F is much steeper than A and B, so we're expecting a different answer in this case. So my point E is 2 minus 2, and my point F is minus 1,5. So again, I'm going to go ahead and I'm going to label my x1 and y1 values, x2, y2, so I don't get confused when I'm subbing them in. M3 is equal to y2 minus y1 over x2 minus x1. That was the slope formula we had on the flashcard. So I'm going to fill in my values. So y2 is 5 and y1 is minus 2. So I've got 5 minus 2. And then on the bottom, I've got x2 minus x1. So I've got minus 1 minus 2, because that's my x1 value. So then I've got 5 minus 2, so that's equal to 5 plus 2, which is 7, all over minus 1 minus 2 is minus 3. And because here we have a minus on the bottom, but a plus on the top, that makes our fraction a minus overall. So that's the same as minus 3 over 7. Or sorry, not 3 over 7. Equal to minus 7 over 3. Apologies. So that means M3 is equal to minus 7 over 3. Okay, interesting point here, right? So our two slopes, our first two were positive, and you can see they slope up to the right. But the one we just calculated here has a negative slope, and you can see that it goes down the way to the right. So that brings up an interesting fact about slopes. If it goes up to the right, it has a positive slope, whereas if it's coming down to the right, it has a negative slope. So looking at that diagram, even if we didn't know the slopes, I could tell the slope of AB and CD would be positive, but the slope of FE would be negative. Okay, let's move on to part 4. So I'll draw a little line under this so we can differentiate between the questions. Okay, which slopes are parallel to each other? If two slopes are parallel, they are equal. Okay, so parallel lines have equal slopes. And that is an important fact to remember in coordinate geometry. So that means that if we have a look at the three slopes we've calculated, M1 isn't equal to M3, neither is M2, but M2 is equal to M1. So we know that M1 is equal to M2. We calculated that earlier. So that means that the slope of AB and the slope of CD are parallel to each other. And how you write that in maths is you say M1, or sorry, I suppose we better use the line names. So that means that the line segment AB is parallel to CD. Okay, these two lines here, that's the notation for two things being parallel to each other. It means they have the same slope. You might have heard before that they are two lines that will never meet. They'll just continue off into eternity and they will never meet because they have the same slope. Okay, but it's important. That's how you prove two lines are parallel. You show that their slopes are equal. Okay, next question asks us which two lines are perpendicular to each other. Okay, perpendicular is a different ballgame. So what perpendicular means is that they're at right angles to each other. So if two lines cross and they're perpendicular, it means that this angle in here is 90 degrees. And so is this one, this one, and this one. That's what it means if anything's perpendicular to one another. They cross at 90 degrees. But how do you show two lines are perpendicular? I mean, it looks fairly obvious from the diagram, but you have to be able to prove it mathematically. So, let me see. Lines are perpendicular to each other, or two lines are perpendicular if the product of their slopes. So if you multiply their slopes together equal -1. Okay, and that's your second important fact of this video. Lines are perpendicular if the product of their slopes equal -1. So if we multiply their slopes together, we get -1. Now we've already established that M1 and M2, so A, B, and C, D, are parallel, so therefore they cannot be perpendicular. But let's have a look at AB and EF. And let's have a look at their slopes. So we're going to multiply M1 by M3. So that's equal to, make sure you can still see my page, that's equal to 3/7 by -7/3. Okay. Now I did a video on multiplying fractions, but just as a bit of revision, when we're multiplying fractions, we do top by top. So 3 by 7, or 3 by -7, which is -21, over 7 by 3, which is 21. Okay, 21 into -21 goes -1 times. All right, so what we've just shown there is that if we multiply the slope of AB by the slope of EF, we get -1. So that means that the line segment AB is perpendicular to EF. That little symbol down there, that's the notation for perpendicular. So it means that if we have a look back at this diagram, up here, where AB and EF cross, that angle there, that's 90 degrees. And because AB and CD have the same slope, because they are parallel, that means that EF, the line EF, is also perpendicular to CD. Again, we could show that mathematically, but it would just be the same thing written out again. We could do M2 times M3 and we get the exact same. We would get minus 1. Okay, so the two most important things you should take from this video, sorry, 3 I suppose. 1, the slope formula and how to use it. Okay, there is another one called rise over run. I personally don't like that one as much. I find it a bit more confusing. So I use this one. All right, I might do another video on rise over run in the future. Okay, second most important thing. Parallel lines have equal slopes. You want to show two lines are parallel, get their slopes, show they're equal. Last thing, you want to show two lines are perpendicular, calculate their slopes and multiply them together. If they are perpendicular, so if they cross each other 90 degrees, their product should be minus 1. If you don't get minus 1, that means that the lines are not perpendicular. So likewise, if you're asked to prove that two lines are not perpendicular, you again get their slopes, multiply them together, and show that it is not equal to minus 1. That's how you show how two lines are not perpendicular. Okay, I hope this video helps.